So coming back to our Ferris wheel problem, imagine that initially you're here. Okay, the wheel has a radius of 10 meters. So initially you're, at the moment you're 10 meters above ground. So I've positioned the center of the Ferris wheel so that it'd be in 0, 0. And I'd like to know essentially how high you will be after a rotation of the Ferris wheel of 5 pi over 6 radians counterclockwise. So that'd be a rotation of 150 degrees counterclockwise. So how high would you be? So in other words, if we've got the coordinates of the cabin right here, what would be the y value? Knowing that y value, we could add it to 10 because the this is already 10 meters here. So we need to add this quantity here. This is what we're trying to find, and we add it to 10, and then we'd find the height. Okay. So all this to say is for this to be resolved, we'd have to find for this problem to be solved, we'd have to find the x and y coordinates of this point. Okay, so I'll show you that. Okay, we'll go back to this problem afterwards, but it's going to turn out to be very similar to finding the y coordinate of a point on the unit circle. So now we're going to just go back to the unit circle, and we're going to go back to the Ferris wheel afterwards, where we're turning, okay, counterclockwise by 5 pi over 6, and we want to find out the coordinates of this point. Now the coordinates are going to be the cosine and the sine of theta. So if this is theta here, 5 pi over 6, we need to find, actually we need to find the sine of theta. So find here sine of 5 pi over 6. That's what we want to find. So how do we do this? So I've described in Moodle like the different things you have to do. So first thing is you want to find a coterminal angle with 5 pi over 6 between minus 2 pi and 2 pi. Now, lucky for you, 5 pi over 6 is already in that interval, so no need to do that right now. After that, we need to identify our reference angle. So you're going to see that even though the point we're looking for is in the second quadrant, we're going to work with a point in the first quadrant. And for that, we need the reference angle. So what's a reference angle again? It's the angle between the ray that connects the center to the point obtained after rotating. Okay, so so this ray here, we need to find the angle that's between that ray here and this and the x-axis. So this is our reference angle. So we're going to position it in the first quadrant. So this is the reference angle here. Reference. Let's see if I can spell this correctly. Angle. And what's that reference angle? Well, you have to understand that a full turn, okay, is pi, right? So if you're going about 5 pi over 6, that means that there's pi over 6 left to turn. So that means your reference angle here is pi over 6. At pi over 6, we actually know the coordinates of the point at pi over 6, or those are the points you need to eventually know by heart. So this is root 3 over 2, 1/2. Okay, so so maybe try to do a better job here. This ray here, or this point, it should be a bit closer to here. So let me redraw that circle. So 5 pi over 6 would be somewhere here. In other words, if you reflect this point over there, you're going to get the point associated to the reference angle. So looking at our reference angle, okay, we see that their sine values are equal. Okay, looking at the coordinates of the point on the for the reference angle, the sine value is equal to the sine of the original angle. So sine of 5 pi over 6 turns out to be the sine of pi over 6. They're the same. Okay, So in other words, you're always going to have that the sine, in absolute value, the sine of your angle is going to be the sine of your reference angle. And then you have to decide whether it's a plus or a minus sign. Here it's a plus sign because the sine values are the same in the first and in the second quadrant. Now sine of pi over 6 is 1/2. So that's the sine of 5 pi over 6. So the cosine will be, well, let's add this to the question. If we want to find a cosine of 5 pi over 6, the cosine would be, in this case, if we look at the cosine of our reference angle, it's opposite to the cosine of theta, so it would be minus cosine of the reference angle. So minus root 3 over 2, because one's on the right hand side of the y-axis, the other is on the left hand side. Okay, so the cosines are opposite to one another. So that's how we can find the sine of an angle that's not in the first quadrant using a reference angle. Now if we go back to the Ferris wheel problem, okay, what are the coordinates here of our first point? Well, now it's not 1, 0, right? Because the radius is 10, so everything's magnified by a factor of 10. So instead of 1, 0, it's 10, 0 here. And over here, what are the coordinates of this point? Well, everything's magnified by a factor of 10. So it would be, what did we find? We found that coordinates here were 1/2 and root minus the other way around, minus root 3 over 2 1/2. So everything now is magnified by a factor of 10. So it'd be 10 times minus root 3. Let me put it a little bit bigger. Minus 10 times root 3 over 2. And 10 times 1/2. So in other words, it would be minus root 3, minus 5 root 3 and 5. So 5 is actually this part here. This is 5 meters. So the total height, right? The height after turning by 5 pi over 6, it would be 5 plus 10. It would be, you would be 15 meters high. Okay, so that would be your height here, your final height, 15 meters. Okay, so that was just an excuse for showing you that how useful it is to find the sine and cosine for points on union of circle. You can translate that to a problem involving a larger circle if necessary. We're going to do another problem. This one is purely mathematical. We're going to evaluate, and not with our calculator, evaluate exactly. Okay. So what I'm going to ask you, evaluate exactly. You know, you can't really use your calculator because I want the real value. So the value is root 3 over 5. That's what I want. I don't want an approximation using the calculator. So you can't just type that into your calculator. That's not going to give you an exact value unless it's actually a rational number that you can actually guess from the numerical value on your calculator. So, but here I want to practice the steps, right? So first thing is minus 14 pi over 3. Okay, this is not in the interval, right? This is not, okay, this is not part of the interval minus 2 pi, 2 pi, okay? So that the first thing I'm going to find a coterminal angle with that. So I'm going to remove some rotations from that angle. Okay, so every time we if we add the 6 pi over 3, we're going to fall back to where we were because 6 pi over 3 is 2 pi, right? So by adding 2 pi, we're going to get a coterminal angle, and eventually we're going to get one that's in the required in the interval minus 2 pi. 2 pi. So minus 4 pi over 3. How many 6 pi over 3 can I add? I can, let's write it like that. If I add, I could add 2 times 6 pi over 3, I think, right? Because that would be 12 pi over 3. That was going to give me minus 2 pi over 3. So here we go. Now this one is in that interval here. Okay. So first thing is that the cosine of the angle we're looking for is the cosine also of this angle minus 2 pi over 3. Okay, I could have added also another 2 pi to fall back with a positive angle. That's also possible. So cos of minus 2 pi over 3. All right, so this angle is coterminal. Okay, so it shares the same cosine. After that, I'm going to find a reference angle. So let's try to draw this angle here. Minus 2 pi over 3. What is that? So this is a negative angle, so we're rotating clockwise. Pi over 2 would lead us here. So minus 2 pi over 3. We need to go like 1 pi over 3, another pi over 3. So it would be ending up here. Right? Okay. So pi over 3 is 60. So minus 2 pi over 3 is minus 120, right? So that looks like minus 120. So this is this angle is minus 2 pi over 3. Okay. So the reference angle is here. That's the reference angle. This is therefore pi over 3. So I need to look at an angle of pi over 3. Okay. So the cosine of minus 2 pi over 3 in absolute value is the cosine of my reference angle. So cosine of pi over 3, what is that? That's this is the point I need to know by heart. So it's a triangle with a small base, right? So 1/2 is the first coordinate. Square root 3 over 2 is the second one. Okay, so from this I can recover the cosine. That's 1/2. Okay. And finally, for my cosine of minus 2 pi over 3, I need to determine if it's going to be plus 1/2 or minus 1/2. But notice here that cosine is negative here, right? So I need to take the negative of that. So cos of minus 2 pi over 3 is minus 1/2 because we're in quadrant 3, right? In our picture, quadrant. So this is why I chose a negative 1. And that's it. So that's equal to the, so therefore, right, let's put everything together. Therefore, let me try to spell that correctly. Therefore, the cosine of minus 14 pi over 3 is equal to minus 1/2.